Hello everyone, welcome to another update on Kwyll. An interesting one this week, or maybe not a week, maybe a little bit longer than a week. There's a good reason for that. Got dragged down into a bit of a rabbit hole, which I'll explain a bit more about during this update. So this one's going to be all about sound. So one of the remaining features that's needed to get Kwyll into a shape where there's the potential, at least, to create a game was always sound. My plan for that originally was to use the BeepFX library that's part of Z88DK, which is a very lightweight, very small assembly beeper effects player by a guy called Shiru. I hope I'm pronouncing that correctly, who very kindly made it public domain and available for anyone to use on a very permissive license. So part of what comes with Z88DK alongside the inclusion of that simple library is a bunch of built-in sound effects that can be used or not used, and they get included in the build when they're referenced. And my plan originally was just to create a simple node in the Kwyll logic that allows you to reference those 40 or so default sound effects. Just a simple node that you provide an integer value, a number, and it just plays that sound. So that's what I did originally, and it worked very quickly. I was able to get that running in the emulator on the Spectrum very quickly. But the problem I then faced, that I hadn't considered when I'd decided to go down that route originally, was how do we deal with it in the simulator within Kwyll? So obviously you're going to want to, when you're designing your game and playtesting your game within the simulator, to make sure that your logic is doing what it should be doing, you're going to want some sort of feedback on the sound. So I played around with various ideas on that front. I looked at trying to deduce or decode how the player works, how it generates its sound, and maybe reproduce that to create a waveform in GDScript. So instead of taking the code that's created by Shiru for the player on the Z80 and try to reproduce what it does, but in GDScript, to create a wave file that could then be played, that would be close enough to be acceptable. However, that proved to be a lot harder than I could possibly have imagined, because the player is very much tied to the instruction timings on the Z80 and the way that the Z80 works in terms of turning on and off the beeper to sample it. So I fought with that one for a little while before deciding that I couldn't get it to generate a sound that was close enough to the sound you get out of the Spectrum, and decided to abandon that idea. So the next idea was to look at what Shiru himself did, which if you do a Google search for the Shiru tools, you'll find that the BeepFX comes with a Windows sound creator tool, which obviously allows you to play the sounds. So I had a quick look into the source, which again he very kindly provides, and tried to understand how they were generating the sound within the tool. Didn't take me long to realise what they were doing. They'd actually included a full Z80 emulator and the Z80 code for the player, which they run in the background, sample the output from the beeper, the virtual beeper in the emulator, and then generate a wave file from that. So that didn't leave me any further forward. I was kind of hoping to find some C code or something that I could reuse and repurpose in GDScript to do the same thing. So then I was left in a difficult situation. If I wanted to create these sounds in the same way that Shiru did, which seems to be the only way of getting something reasonably accurate, I felt I was faced with two possibilities. Hi, editing Paul here. I realised when watching this, when I was putting it together, before uploading that I actually missed out a third possibility. There were three possibilities. The first one I actually did try, and it was seriously considered as the best way of getting something done very quickly, which was actually to cheat by creating a Z88DK, a very simple Z88DK executable program on the Spectrum that plays all of the default sounds one after the other, record them from an emulator, and then in a sample editor extract each individual one as a WAV file that I bake into Kwyll. So you have all the default sounds that are built into Z88DK as WAV files that can then just be included, and that would supplement the idea of just having this simple logic node that just can play one of the 40 or 50 default sounds and no editing capability whatsoever. So that was where I was headed before, but in the back of my mind I always felt that would be a bit of a cop-out, so hence the two options that I mentioned a moment ago, and I'll go into a bit more detail now. Okay, back to real time. Firstly, I could take in a C-based Z80 emulator, possibly even the one that Shiru uses, because it's just a couple of files, a C file and a header file. It's very simple and should be very easy to include, and then build that into a GD extension in Godot so that it could be included with the product. This is something I might return to at some point. I did look into that, and I looked at a couple of other open source Z80 emulators to see if it was any easier, and came up with a couple that did the job very easy. And I even looked into getting a GD extension built for a little while. Again, something not too difficult to do, but what put me off a little bit was changing the build process for Kwyll at this stage to include cross-platform GD extension stuff. It's something I'm probably going to have to do at some point anyway, because I'd like to bring in a proper Z80 emulator for other reasons, not just for the sound. But I really wanted to try and avoid that if at all possible at this stage. So I took my second approach that I had in the back of my mind, which was to write a rudimentary Z80 emulator in GDScript. So that's what I did for 2 days, writing just enough Z80 emulation code in GDScript that's reasonably cycle accurate, just enough to run the instructions that are required for the 232 bytes of the BeepFX player. So basically just implementing instructions, running it to see where it hit an instruction it didn't understand, implement that instruction, and rinse and repeat until I got something that did, but at least ran all the instructions. It then produced utter nonsense in terms of sound, but then it was another few hours debugging to find out why my instructions weren't working or the flags weren't being set correctly. Eventually got it to produce some sound. So that's what we've got at the moment, and I'm fairly happy with it. It's not fast. It was never designed to be fast. It just does the job. It generates a sound by pretending to be a spectrum for a while. So then I turn my focus on what that means for Kwyll itself, because now that I have the ability to generate sounds inside Kwyll from arbitrary sound BeepFX sound definitions, I'm no longer tied to the predefined set of sounds that Z88DK provides. So I decided to take the leap and implement a sound editor, a BeepFX focused sound editor in Kwyll. So that's what we've got. So I'll switch over to the editor quickly, and I'll show you how it works. So you've got this new tab up here, sound. You'll see within here there's a tab section as well, and there's only a single tab at the moment, BeepFX, and that's because obviously at some point in the future I'll have different sound approaches, including hopefully not too far in the future AY sound for the 128K spectrum and its ilk. But for now it's just BeepFX, which should be enough just to give us what we need. So this is modelled This editor is modelled a little on the, or largely in fact, on the Windows app that Shiru provided, but then modified to fit within the Kwyll look and feel, and changing some of the things over here to make them a little bit more friendly. So what you have is you have a list of effects. Each effect you can add new effects and delete them in here. Each effect consists of a list of blocks. There's up to 128 effects and 128 blocks per effect, although I wouldn't recommend you get anywhere near those limits. And each block, so this is one block in here, so this fire effect has a single block of type tone. Each block can be one of tone, noise, or pause. There is a fourth one in the beep effects library for sample, but I just haven't implemented that yet because I'm not sure about how to get in sample data, and I didn't want to address that problem at this point. This is sufficient to do basic sound effects. So a tone block plays a square wave, and you've got a bunch of parameters here that control how the sound is generated for that particular block. I'm not a sound engineer. I don't understand sound generation particularly well, but I'll try and explain a little bit from my understanding of what each of these parameters means. So you've got two durations, frames and frame length, and the reason you've got two durations is you have these sliders here, these pitch and duty sliders, which affect the pitch and the duty values, which I'll explain again in a moment. But these sliders change the value of, so this slider value, although that's a slider, this slider value will change the value of the pitch over time while it's playing the sound, and similarly any value in here, positive or negative, will change the value of the duty parameter over time. But you don't want to do that every frame all the time constantly, because that gives you limited control. So the actual duration of the sound is split into two durations, two parts, a number of frames and a length of each frame. And the slide modification is only applied at each frame. So if you have a length of 110 frames, the pitch will be slid by this amount 10 times, once at the end of each frame. In between those frames, the same waveform is played constantly. So that allows you to control how you split up the time. So if you've got something that involves a much smoother slide, then you'd probably choose a smaller value here and a larger number of frames, so it changes more. If you want a step type change in your pitch or your duty, then you'd probably choose a larger frame length and a smaller number of frames, and then it'll step the pitch and duty change over time. So that's those two and how they work together. They're both on sliders. They can go up quite high because some of the sound effects that I pulled in from the library did use high values, so that makes it very difficult to get very fine with the slider. So hence you've got the up and down and text editor as well, so you can get fine grain control to control those. The pitch defines the frequency of the square wave that you're generating, as far as I understand. I'm not sure what the number means, but it's in terms of the cycle time of the player. So it's defined it's tightly very associated with the player itself. So I don't think it can be easily mapped to a hertz value or a frequency value, but it's a value, and you modify it to get the sound that you want. The pitch slide is a signed value, so it can go up or down. So if you want to pitch slide up, then you'll get the high over the duration of the sound. The pitch of the tone will increase. Obviously, if you go down, then you get a decreasing pitch. The duty, again, I've had to look into what the duty cycle of a square wave means, but my understanding is that it's the ratio between positive and zero pulses. So a square wave is 0 pulses going straight up to a positive pulse, going down to a negative pulse, and the duty is the ratio between how wide it is at the top of the square and how wide it is at the bottom of the square, and you can control that. 0 to 1 is obviously the ratio, but this is a value between 0 and 255 that So if it's up at 255, the square wave will basically be a constant pulse up at the high. If it's down at 0, it'll be 0, so you get no sound. And at 50 or 128 at 50%, it's going to be a perfect square wave up and down. And the two slides work very much similarly. So this is a smaller minus 128 to 128 modification that will be applied at each frame to the duty cycle, so you can change that. The duty, as far as I understand, changes the tone or the tone color of the square wave. So it's used to create less perfect sounds, less pure sounds. So that's what you get for that one. And then you can switch to a noise. Noise is a little bit simpler. You have the same 2 frames and length that mean exactly the same thing, and then you've got a pitch and a slide, but the pitch is less accurate because it's generating noise rather than a tone, so the pitch doesn't really work in the same way. But you can increase and decrease the pitch throughout the sound using the slider, the slide value as well. The noise, for anyone who's interested, and this is something to do with Shiru, not me, but it's quite cool, that it just basically reads data out of the first 8K of the Spectrum ROM, which is the basic ROM, which it turns out is close enough to random data to be useful for noise. So that's quite an interesting thing. So that's how it generates noise. And the third block, the pause one, is very simple. It just pauses for a period of time, and that's just got the frames and the length. Having the frames and the length allows you to have longer pauses than you would be able to have otherwise, but you can mix these two to generate the pause that you want in between blocks. So you place these blocks by just adding them, and they'll play in turn in sequence, and you can move them up and down using these arrows, so you can change the order. You can clone one and delete it and so on, so you can generate complex sounds using this whole thing, and then just rename them. So if you add a new one, it comes out with a simple name first, which you can then go on and replace and add your tones and so on. So I won't go into actually generating sound because I'm not good at that sort of thing, but I'll load up a test file that I've got that I've basically gone through the standard library that comes with Shiru's tool and replicated them inside of here. So we've got all 55 of the standard library of sounds. There are 3 additional ones. I think there's 58 or 59 in the actual library, but they use the sample feature, which I'm not using at the moment, so I just haven't included those. So this will be included in the sample data, so you can go through and get some idea of how the expert, Shiru, not me, puts together sounds and what it can do. But basically what it does under the hood now is it'll take this block definition. So this is a very simple one. It's a simple single block tone with these parameters, and when you hit this play button, it's actually running up my GDScript Z80 emulator, loading it with the player, loading it with the data from here as a block of bytes, and then running the player and sampling the output port of the beeper at 44.1 kilohertz, and then generating a wave file which it plays with in Godot. And what you get is that. We're going to have a look at some of the more interesting ones. So there's jumps, grab sounds, there's a fat beep. So this one's interesting because you've got 20 frames at 1,000 ticks per frame, so it's quite a long one. The pitch is quite low, and then it slides the duty. So it starts off a duty somewhere in the middle, so 50-50, and then it reduces the duty, so you get less of the high, the positive signal on the square wave, and more of the negative, the zero. And what you get from that one, there's a few of those, which are quite interesting. So that colour, that tone, you can hear in the background. So it's not a pure square wave. Is a result of changing this GDScript. You can get some harsh ones as well. This is an interesting one using pure noise, and again a very long one, and then a pitch change. Got some interesting booms. Some of them down here, further down. Yeah. So this one shows you the power of having multiple blocks playing in sequence. So these aren't particularly long blocks, but when you put them all together, you quite a complex sound. So it's quite powerful if very simple. And switches. This one's interesting. So this uses a lot of frames of very small length, and then a dramatic slide. So the slide, because of the number of frames and the length of each frame, the slide will result in the pitch or the duty overrunning and cycling round. So you get this interesting effect. It's quite clever. They do sound pretty much the same as this on the Spectrum, but I'll show you in a moment. We've got some more here, alarms, simple alarms. This one's interesting. So this is a single tone, but again you've got these extreme slide values here, which just overruns the limits of the 16-bit integer and results in sort of a random. You'll notice that there was a slight delay when I first pushed play. That's the Z80 emulator in GDScript running the sound player and storing the wave, but then it caches it, much like the bitmaps that are used throughout the rest of Kwyll. So it'll be held as a bitmap until one of these slider changes, a cached wave file, until one of these sliders changes, so it can replay very quickly. So in this sample file, I've also got a single room with some logic in it that just uses this new node for playing a beep effects. So if you disconnect the input as an integer, you can then select from the list directly, or pop in and play a sound chosen programmatically. So what this does at the moment is it's got a single variable FX, which it increments right through to 55, left and right keys up and down. It puts the value into the single instrument on the screen, which you can see here, and then plays that sound, and just allows you to go through all the sounds that are in there very quickly. So if we look at that in the preview, so you've got sound 0. If I push fire, 2, right up to clang and 55 our old computer. So we've got some sound, which is good, and just very quickly show you what it looks like when you export. If I go down to the bottom, so it exports all of this data. So each one of those is one FX, and then you've got a list of the pointers to them, which the node can use, or the code can use. And if we do an export quickly, the build is now infinitely faster than it ever was. So you saw that's only a few seconds, because there's very little code thanks to the switch over to virtual machine logic. So it's just all data, which compiles really quickly. So that's exported now. If I switch quickly to the emulator and load that file in, fingers crossed, so it shows the same thing with the same left and right. Playing the same sounds but in the emulator, in the Spectrum. So if we go up to 55. So you can hear they're not exactly the same, because obviously generating a 44 kilohertz wave file is going to be slightly different, but similar enough that you can work out how they're going to sound in the game, and then move them across and get an idea. So that's it for this one, all about sound, and hopefully that one's ticked off now. I will be releasing an early a new version to the early adopters on Discord probably tomorrow. Now it's quite late here, and let them play with that and see what happens, see how well the Z80 emulator code holds up when they start hammering it. And then I think I'm getting close to almost feature complete. I've got a couple of other things I'd like to put in. Mainly I want to be able to put the I want to have the ability to draw with tiles on the screens. So if I switch back to the screen, the editor again, so at the moment all you can do in a screen is place instruments and your game window. What I'd like to be able to do is extend that to be able to draw in these areas outside of the game window with tiles that you've created in here, so that you can make more interesting screens and menu screens and so on, that just makes your game feel a little bit better. I should probably leave it at that for now. I've put out a request on the Discord, so if anyone wants to come along on the general channel and make any suggestions about what they think ought to go in before release 1, because I'm heading now towards locking down the feature set for release 1. So if there's anything you think would be really useful to have in there, essential, because I'm looking for a minimum viable product really, pop into the Discord and let me know, and I'll make sure. So the idea is that over the holidays I'm going to be working on finishing those features up, shoring up some of the problem areas and smoothing off the rough corners, and hopefully by early next year we should be in a position to have an early beta test out, and then from there, depending on how well it goes, finally a release 1. So as with all of these, if you're enjoying what you see, don't forget to subscribe and leave a like. Pop over to the Discord and say hi. There's quite a few people over there now, so we can get some good conversations going about game creation in here. And I'll see you next time. Thank you.